Hello again. We are going to start talking about how to apply derivatives to real life situations. And our first topic is going to be time rates of change. So let's have a look at that. There's a bunch of situations that involve time in them in the real world. You can talk about whether you're driving down the road so that your independent variable would be hours and your dependent variable would be the number of miles that you travel in those hours. You could talk about a baseball player throwing a pitch, in which case the independent variable would be the seconds that it took, and y would be the distance in feet. You could talk about a city and the population over a certain number of years, and you could talk about, let's say, the growth of a tree over a certain number of days. You could be measuring the height over a certain number of days. All right, so with each of those, the independent variable is time, whether it's hours or seconds or years or days. So what we do when we find the derivative, we are measuring it in whatever the y units are per whatever the x units are. So if I'm driving down the road, I might measure my change, my instantaneous rate of change in miles per hour. For someone throwing a baseball, the rate of change would be in feet per second. For a population of a city, the rate of change might be people per year. And then for the growth of a tree, the rate of change would be in inches per day. All right, so here's an example. If a ball is thrown upward and its height h in feet at time t in seconds is given by that function there. H of t equals negative 16t squared plus 18t plus 100. Okay, what's the velocity of the ball at any given time? What's the velocity at two specific times, 0 seconds and 2 seconds? And what is the velocity when the ball when it hits the ground? Okay, so to find the velocity of the ball at any given time, I simply take the derivative. So the derivative of negative 16t squared is negative 32t. The derivative of 18t is 18. And the derivative of 100 is 0. So that is the expression that gives me my derivative for any given time t. Now I can use that to answer the second part. What's the velocity when t is 0 and when t is 2? I simply need to plug those x values in to my new velocity function. So at time 0, the velocity is going to be negative 32 times 0 plus 18, and that's going to be 18 feet per second. And then at time 2, the derivative is going to be negative 32 times 2 plus 18, and that is negative 46 feet per second. So that actually means that it is falling. Okay, so to figure out what the velocity is when it hits the ground, first of all, I need to figure out when does it hit the ground. I need to figure out when is the height of the ball going to be equal to 0. So I take the function for height and I factor it into negative 2 times t plus 2 times 8t minus 25. And I set that equal to 0, and my solutions are t equals negative 2 and t equals 3.125. Well, negative 2 doesn't make sense as a time, so I'm only going to use 3.125 as my time. And if I plug that into the derivative function, I get negative 32 times 3.125 plus 18, which is negative 82 feet per second. So it was falling down at a speed of 82 feet per second. All right, so that is just some quick examples of time rates of change. If you have any questions, please let me know, and I will see you tomorrow.